Hello everyone, this is Mustafa Youssef. Welcome to this course, which is Introduction to Programming using MATLAB. This course will take you from the very basics of programming until you are able to write codes for engineering and scientific calculations. We will start first by a very basic introductions. We don't have assumptions about the background of the audience, and we will gradually and systematically build on the basic information that we will discuss now. So let's start with something really very basic, which is computers. What do computers really do? One way to think about computers is to say that these machines, they are actually doing two things. They are doing calculations, and in fact, they are really excellent in doing this, so they can do billions of calculations per second. And another way to think of them is that they are capable of storing. So they can store tons of information in a very small space. And again, this also hints to the large memory that computers have and allows them to store several data. Nowadays, we can see these data in terms of text, audios and videos, and so on. Now, let's in particular focus more on calculations, because that's the main purpose. We would like to learn programming so that we are able to compute and calculate. So we can think of calculations in terms of two things. There are sort of built-in functions in the computer that we can just use. The basic things we can think of are the arithmetic operations, so we can use these right away, or we can write our own programs. So we can write our own programs which can compute something more sophisticated and more complicated. For example, let's think in terms of an engineering point of view. We can write a program that calculates the pressure of a gas given certain conditions, for example, temperature, volume, and other properties of the gas. So these are the types of the calculations that the computer can do, either ones that are already there, available for us. And in fact, as we will learn MATLAB, and even if you learn other programming language, you will see some other functions available for you, like the standard sine, cosine, tan function, square root function. So these are all built-in functions available for us to use. It doesn't really hurt to have an overview of what a computer looks like. And this is really a very basic point of view, rather than something sophisticated. So let's think of what the computer is really looks like. So a computer, we can think of it as a central processing unit, the unit that actually performs the calculations. And again, this is really ignoring the other units that could be available for computing, other modern units available for computing. This is a very classic and traditional view. So there is the central processing unit. There are also some input devices that can allow us to enter information to the computer. So these input devices, the simplest of them is the keyboard, for example, the mouse, any input device like a pad or something on which you can write and enter data to the computer, or even voice, recording voice can this also be considered as an input to the computer. And another thing that we can get is from a computer is the output, and that output can actually also appear in several formats. So this could appear on the screen, could appear using a printer, or any other output device. Another thing that's also very crucial and very important and very fundamental is the main memory, um, main memory connected to the CPU, to the central processing unit. And there are actually two types of memory here. There is the random access memory, and that's on the order of, let's say, 8 gigabytes all the way to even terabytes, maybe 1 terabyte or even more, depending on how powerful your computer is. And there is also the cache memory available for the CPU. Now, in addition to this main memory, there is also a secondary or auxiliary memory, which is different and usually much larger and much cheaper. So let's see. So here we have auxiliary memory. Here we are thinking of something like the hard disk, and that's actually could be up to 2 terabyte or even more, depending on how much storage you want for your data. So this is a very, very brief idea of how does a computer looks like. We would like to give a hint about the memory units. So this is something that's a reminder about the memory units here. You probably have heard about 1 bit. The bit is a small unit of memory. It usually accepts either 1 or 0. You can think of it as up or down. So it has only 2 possibilities. But there is a larger unit of memory, which is byte. And that byte is usually 8 bits. And now out of the byte, you can have multiples. So you can have kilobytes, which is 1000 bytes. So this is 1000 bytes, or you could have also mega, giga, tera, and so on and so forth, all these available multiples for you. So that's a very basic idea about a computer. How does it look like? Of course, there is no intention here to discuss in depth this topic. It's just what's needed for us in our programming study. Another point that we would like to discuss is the type of programming languages. In fact, there are many types and there are many ways to classify programming languages. So programming languages, there are really many types to classify them. And there are many of them. But we will really talk about the most important ones for science and engineering calculations. We can classify these programming languages into 2 types: compiled languages and interpreted languages. And let's give classic examples here. For the compiled languages, the classic examples are C++, maybe Fortran, an old but still used language. In the interpreted languages, we have MATLAB, and we have also Python. So these are the different or examples of languages that falls under the interpreted languages and the compiled languages. Now, what is the difference? The difference is the following. For the compiled languages, you write a whole code, complete code, and then there is another software called compiler. The compiler scans and reads the whole code, checks for syntax errors, and then if there are no errors, it produces a version of the code that's ready to execute. And then you can execute the code at once, the whole of it. While the interpreted languages are different. So the interpreted languages, you write a code, and then the computer starts to interpret or calculate line by line, in the sense that there could be a mistake or an error or a syntax error somewhere here, but it will not be discovered until the computer actually reaches to this point. In other words, if the first lines of the code are correct, so they will be calculated correctly, but then once we reach to the error place, the code will stop and you will likely see an error message. Now, there are other differences, of course, but I have very minimal comment about these differences. And the key ones are the following. Usually learning these is a little bit harder. So it's a little bit harder to learn C++ or Fortran in a first exposure to programming. While for MATLAB and Python, I believe these are much easier for different reasons, which will be discovered as we go deeper into this course, and every now and then we can make these comparisons between compiled and interpreted languages. But on the other hand, so this, you can think of this as the plus for the interpreted languages, and this is a minus for the compiled languages. But there is another factor. So the compiled languages are usually, the code that you write is usually fast, much faster than the interpreted languages. And that's why in areas of high performance computing, there is really focus on the compiled languages rather than the interpreted ones. While the interpreted ones are usually slower than the compiled languages. We think of these are as a little bit slower compared to the compiled languages. And how much faster and how much slower, that depends on the code. How did you write it? Did you actually you really use all the advantages and the possibilities in the interpreted languages? Something that we will try to cover during this course. All right, so let's stop here and we will continue in another segment.